Hi everyone, welcome to ParkTechTalk. I'm Brian Lundgren, and today I want to talk about conducting trials at a cast film biaxial orientation laboratory to achieve desired properties for sustainable plastic. So currently, there is an increase in awareness in our society regarding the negative impact or negative effect of plastic waste in our environment. One solution to this legitimate and very complex problem is the use of biodegradable polymers based on renewable organic materials of biological origin, such as PLA and PHA. However, for these types of biodegradable polymers to be used as a viable alternative, they must achieve or at least approximate the properties of commodity polymers. So many researchers have turned to stretching processes or orientation, and specifically biaxial orientation, which is the heating and stretching in the machine direction orientation and transverse direction orientation to achieve the desired properties in film and sheet. However, not all orientation processes deliver the same results in attempting to achieve those essential properties. There are multiple methods to produce sustainable bio-based plastics, including injection molding, blow molding, thermal forming, and blown film. Most of these methods offer varying degrees of orientation to modify the properties to make the polymers more suitable for particular applications, such as food packaging, which is the leading global production usage of all plastic materials. However, cast film extrusion with biaxial orientation has been proven to provide the most benefit. So cast film extrusion uses a slot die to continuously extrude onto a cast roll, which the cast film is continuously oriented, first in the longitudinal or machine or MDO direction, and then oriented in the transverse direction. So the combination of these two stretching processes results in a film that is essentially biaxially oriented. Since the film is extruded on a flat plane, the material can be heated and stretched in a higher ratios with less shrinkage, offering the following benefits compared to other orientation processes. So you're getting better gauge control at lower thicknesses, you're getting better gauge uniformity when compared to blown film, you're achieving higher tensile strength at the maximum stretching ratios, and you're achieving better barrier properties, again, over blown film. So research and development teams continue to work on viable alternatives to commodity polymers and rely on research facilities to test their blends. At Parkinson Technologies, here in Woonsocket, Rhode Island, we have a plastics orientation lab, providing a convenient and confidential environment for polymer extrusion and orientation work on a full-scale pilot line capable of producing oriented product up to 2 meters wide. So researchers can conduct product and process development trials and produce samples for test markets and conduct semi-production runs. So the lab not only offers a means to conduct trials in sustainable plastics like PLA and PHA, but also engineering thermoplastics like PA, PET, and PETG, high-temp resistant thermoplastics like PTFE, PVDF, and PEEK, and commodity thermoplastic. So for more information about our plastics orientation lab, or if you'd like to inquire about any of our brands, including Marshall & Williams Plastics, Parkinson Winders, Duesenberry Converting Systems, and Key Filters Melt Filtration, please visit our website at parkinsontechnologies.com. Thank you.